Hello everyone, this is Kalpana here. In this video, we are going to solve a second order linear differential equation from higher order linear differential equations with variable equations. So let's get going. Problem solve d square minus 3d plus 2 into y equal to cos of e power minus x using variation of parameters. Given differential equation, d square minus 3d plus 2 into y equal to cos of e power minus x. Consider it as equation number 1. So we need to find the general solution of the given differential equation using y equal to yc plus yp. Here, since the equation is of the form f of d into y equals to some function of x, right? So we'll find yc using the auxiliary equation, right? Where f of d equal to d square minus 3d plus 2 the auxiliary equation is f of m equal to 0, where f of m equal to, just replace the differential operator of f of d with m, then we'll get f of m equal to m square minus 3m plus 2. Then our auxiliary equation becomes m square minus 3m plus 2 equal to 0. We'll split minus 3m as minus 2m minus m plus 2 equal to 0. Now take m common from the first two terms, we'll get m times m minus 2, and take minus common from the next two terms, we'll get minus of m minus 2 equals to 0. Now we are having m minus 2 in both the terms, so let's take m minus 2 common, then we'll get m minus 2 into m minus 1 equal to 0, right? M minus 2 into m minus 1 equal to 0. Now we equate each factor to 0. When m minus 2 equals to 0, we'll get m equals to 2. And from m minus 1 equals to 0, we'll get m equals to 1, right? Then m equal to 2 and 1 are the roots of our auxiliary equation, which are real and distinct, or m equal to 1, 2. Therefore, the roots are real and distinct. We know that when two roots say m1 and m2 are real and distinct, then yc will be c1, one constant into e power 1 root into x, plus c2 into e power another constant into e power another root into x. Okay, let's now write yc. Complementary function is yc equals to c1 into e power, we are having m equal to 1, 2, right? Let's take 1 first, plus c2 into another root 2 into x. This equals to c1 e power x plus c2 e power 2x. So we got yc equal to c1 e power x and c2 e power x, right? Just compare this with yc equals to c1u plus c2v, where u equal to e power x and v equal to e power 2x. Let the particular integral of the equation 1 be yp equal to au plus bv, that is yp equal to a into e power x plus b into e power 2x. We'll just replace c1 and c2 of yc in YP, just replace C1 and C2 by A and B, then we'll get YP. Now we'll find A and B using the formula given by variation of parameters method. Okay. A and B are given by A equal to integral minus VR by uv1 minus uv1 into dx, and B is given by ur by uv1 minus vu1 into dx. So before finding A and B, we'll just find uv1 minus vu1 because it exists in both the formula. And we have to remember that the denominator must be non-zero. Firstly, let's find uv1 minus vu1. See, we are having u equal to e power x. Then u1 is derivative of u with respect to x, which is equals to d by dx of e power x. Just differentiate on both sides with respect to x to find u1, which is equals to derivative of e power x with respect to x is e power x, right? So u1 is e power x. If we are having v equal to e power 2x, then find v1. Just differentiate on both sides with respect to x. Derivative of e power x, e power 2x with respect to x is 2 into e power 2x. If v equal to e power 2x, then v1 is 2 into e power 2x, right? Let's now find uv1 minus vu1. U e power x into v1, 2 into e power 2x minus v. V is e power 2x into u1 e power x. u1 is e power x. This is equals to 2 e power x into e power 2x minus e power 2x into e power x. E power x into e power 2x is e power 3x, right? Minus e power 2x into e power x is e power 3x. See? Okay? This is equals to 2 e power 3x minus e power 3x is e power 3x, which is non-zero. Okay? Therefore, uv1 minus vu1 equal to e power 3x. Now let's find A and B. See, A is given by minus VR by uv1 minus vu1 into dx, right? This is equals to integral minus v, which is e power 2x into r. See here, cos e power minus x is our r. Okay, you'll get cos of e power minus x by uv1 minus vu1, which is e power 3x into dx. This is equals to integral minus e power 2x into cos of e power minus x into, we can write 1 by e power 3x. I just wrote this fraction like this. Now I'll take the minus outside the integral. E power 2x cos of e power minus x, we can just write directly, okay? E power 2x minus e power 3x is e power minus x. You can just write e power minus x in the next step itself. But to make clear, I'll write 1 by e power 3x as e power minus 3x into dx. This is equals to minus integral e power 2x into e power minus 3x into cos of e power minus x into dx, which is equals to minus e power 2x minus 3x into cos of e power minus x into dx, which is equals to minus e power 2x minus 3x is minus x into cos of e power minus x into dx. Okay, let e power minus x equals to some t. Now differentiate on both sides with respect to x, then we'll get derivative of e power minus x with respect to x is minus e power minus x equal to dt by dx. From this we'll get minus e power minus x into dx equal to dt, right? Or e power minus x dx equals to minus dt. Okay, now see we are having a equal to minus e power minus x cos of e power minus x into dx, right? We can just take this minus inside the integral, or we can utilize e power minus x dx equals to minus dt. Okay, so I'll write this as cos e power minus x into e power minus x dx. In the next step, either we can replace e power minus x dx with minus dt, or just take this minus inside the integral and replace minus e power minus x dx with dt. Okay, I just wrote minus inside the integral, so I'm going to write or replace minus e power minus x dx with dt. Okay, then a becomes integral cos, replace e power minus x with t and minus e power x dx with dt. We know that integral cos t dt is sin t. Since t equals to e power minus x, then we'll get sin e power minus x, right? So we got a, therefore a equal to sin of e power minus x. Now we need to find b. We got a. Let's find b. B is given by integral ur by uv1 minus vu1 into dx. This is equals to integral u e power x into r cos of e power minus x by uv1 minus vu1 is e power 3x into dx. This is equals to, here I am going to write e power x by e power 3x directly, e power x minus 3x, or better I'll write 1 by e power 3x as e power minus 3x into cos of e power minus x into dx. Okay, if you want I can write 2 more steps. I'll just write this fraction as e power x cos of e power minus x into 1 by e power 3x into dx, which is equals to integral e power x cos of e power minus x into reciprocal of e power 3x is e power minus 3x into dx, which is equals to integral e power x into e power minus 3x into cos of e power minus x into dx, right? And we know that e power x into e power minus 3x is e power x minus 3x, which is equals to e power minus x minus 3x is minus 2x. We'll get e power minus 2x into cos of e power minus x into dx. Let e power minus x equals to t. Now differentiate on both sides with respect to x. Derivative of e power minus x with respect to x is minus e power minus x equal to derivative of t with respect to x. Now bring this differential dx to LHS, we'll get minus e power minus x into dx equals to dt, or e power minus x into dx equals to minus dt, right? So here we are having e power minus x into dx equals to minus dt, right? So I'll split e power minus 2x as e power minus x into e power minus x for my convenience, so that in the next step I can replace e power minus x into dx with minus dt. Okay, I took 1 e power minus x with dx. Okay, so we are having 2 e power minus x. So 1 I'll write for t and 1 I'll take it for dt. Okay, so now put e power minus x equals to t. Just replace e power minus x with t, then we'll get t cos t into, replace e power minus x dx with minus dt, so that it will be easy to evaluate. Minus t cos t into dt. Here we need to use integration by parts formula to find integral t cos t dt. We got b equal to minus integral t cos t dt. Let's now apply integration by parts formula. Integral u dv equal to uv minus v integral v du. So we are having integrand, which is the product of polynomial function into exponential function. We'll take the polynomial function as u and the remaining part as dv. Then we'll have u equal to t and dv equal to cos t dt. Now differentiate on both sides with respect to x, we'll get, with respect to t, then we'll get derivative of u with respect to t equal to derivative of t with respect to t is 1. From this we'll get du equal to dt. Here integrate on both sides to find v, we'll get v equal to integral cos t dt is sin t. Now we can just apply this formula. We'll get integral u dv, u is t, into dv is cos t dt, equal to u into v, t, u is t, into v is sin t, minus integral v sin t into du, du is dt. This is equals to t sin t minus integral sin t dt is minus cos t, which is equals to t sin t minus into minus plus cos t, right? Since integral t cos t dt equal to t sin t plus cos t, then b becomes minus of t sin t plus cos t, which is equals to minus t sin t minus cos t. Since we know that t equal to e power minus x, so let's replace t with e power minus x. We'll get minus e power minus x sine of e power minus x minus cos of e power minus x. This is our required b. We got a and b. Let's now write yp. Yp is given by a into e power x plus b into e power 2x, which is equals to a sine of e power minus x into e power x plus b minus e power minus x sine of e power minus x minus cos of e power minus x into e power 2x. This is equals to e power x into sine of e power minus x plus into minus minus e power minus x into e power 2x into sine of e power minus x plus into minus minus e power 2x into cos of e power minus x. This is equals to e power x sine of e power minus x minus e power at the powers minus x plus 2x into sine of e power minus x minus e power 2x cos of e power minus x, which is equals to e power x sine of e power minus x minus e power minus x plus 2x is e power x into sine of e power minus x minus e power 2x into cos of e power minus x. So here e power x sine of minus x minus e power x sine of e power minus x gets cancelled and we'll get yp equal to minus e power 2x cos of e power minus x. Therefore, yp equal to minus e power 2x into cos of e power minus x. See, we got yp and already we have yc. So we can write the general solution now. The general solution is given by y equal to yc plus yp, then y equal to yc c1 e power x plus c2 e power 2x and yp is minus e power 2x into cos of e power minus x, which is the required solution. Therefore, y equal to c1 e power x plus c2 e power 2x minus e power 2x into cos of e power minus x. This completes the problem. So we have seen a problem from variation of parameters in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.